everyone, and allow me to start with a quick question. What do you consider to be the greatest sin in testing? Is it testing too little and not providing enough coverage, or not knowing when to stop, or, God forbid, still doing some manual testing? Please use the Slido to share your thoughts. And while you do, I'll try to tell you a quick story, because for me, this question brings me back to my early days as a tester and one of the first big projects that I was assigned to. You know, the complex system, the sophisticated testing process, everything that gets a junior tester all hyped up. So to give you some perspective, this is before Java and cross-functional teams became popular. So I'm part of this regular testing team with our testing lead and Helen. Let me tell you more about Helen, because she's an important person in that story. So Helen is the senior tester. She's been there for quite a while. She knows the system inside out. So she's given the most important task of all, to determine and to manage the testing scope of the projects. So whenever a new feature comes in, this is how it goes. First, the requirements come to Helen. She reads them quickly. She finds that they're lousy and incomplete, like any other specification in time. And she spends something like a couple of hours and quickly starts drafting some testing scenarios. And because Helen knows management, she knows that they don't like any defects slipping through whatsoever. And she's determined to make sure everything gets tested. And I mean everything. Like, for example, these exotic scenarios when a blue moon shines in the sky and it hits your keyboard and you strike a particular key combination and then their software breaks, right? So she throws a couple of hundred like this in there. And then it's time for us to start writing the test cases. And yes, you know, the test cases like preconditions, the expected results, the test steps, everything by the book. And Helen is there all the time to review and make sure we don't skip anything, because, you know, if something doesn't get written down, it might not get tested, right? And yeah, there are questions here and there where all this is relevant or whether we should start prioritizing it, but who knows where defects might come from? And besides, Helen knows the system better than anyone. So this quickly gets overruled. This takes her something like a month for the entire testing team to write the test cases. And then it's high time we started testing because the developers are ready, you know. And at that point, I'm sure you already know what's next. So allow me to fast forward a couple of months and several hundred manual tests later and take you to a pivotal moment, because it's the end of our first testing iteration and we finally get to take a weekend off because we're quite exhausted already. The project, unfortunately, is way past the deadline. Management is furious. And our testing lead is a bit frustrated as well, because he knows that regression is yet to come and there's no automation to rely on, simply because the automation team are still struggling to automate all the blue moon scenarios from the previous project. And what about Helen? She's content because after all, she again gave it all she could and she did her best. Besides, there's no much time for retrospective or lessons learned, because the requirements for the next project are already on her desk. If you ask about me, I'm not so hyped anymore, you can imagine that. But I come to realize something very important, that it does matter how we approach testing. And sometimes, unfortunately, rather often, we pave our own way into testing hell. You know already that my name is Panayot Solakov. I work as a QA manager and team lead in Experian. And although a lot of years have passed since that story I just told you, and a lot about testing and automation and everything has changed since then, I still seem to be facing the same question every day in my work. How do we test it smarter rather than harder? So I'm really excited to be part of the conference and be able today to speak more about microservice testing challenges in particular, and the lessons me and my colleagues learned through our journey of trial and error there. So speaking about microservices, ever wondered why these got so popular? If you Google that question, I'm most certain that you find quickly the 9, 11, or was it 21 benefits of microservices. But to me, it seems that all boils down to one thing. Microservices are meant to be simple. There should be a simple and easy way to get your change from code to production, being it implementation or deployment or scalability wise. So they should be much easier and simple to test, right? Right. Or so I thought when I joined Experian several years ago on a product that was migrating, you guessed it, from monolith to microservices. And actually, I quickly realized that a complex system is still a complex system regardless of how you refactor it. And we're just moving the complexity from one place to another, in this case, from the component itself to the integration and connectivity between all the bits and pieces. So the risk and the testing challenges also shift into that direction. And the big questions become, how do we ensure that this is working together as a whole with so many different parts being released independently all the time? And with so many teams around the world doing implementation and testing with their preferred tools, how do we scale our automation approach and make it consistent? So before diving more into this, let's put in some terms, because with microservices, we often talk about consumers and providers, right? So the consumer is a service that consumes information, and the provider is a service that provides information. It's as simple as that. And yes, sometimes consumers and one service can be both a consumer and a provider, but let's keep it pretty simple for that presentation. So how do these talk to each other? Well, through the magic of APIs and HTTP protocol mostly, right? So here the consumer apparently sends an HTTP request to get some user information, and the provider provides that details as a HTTP response with some payload in JSON format and so forth. And this structure here is actually what we call the API contract, right? And this is actually where the magic of API is, because if both consumer and provider keep this contract, they should be able to talk to each other just fine. And the question becomes, how do we test this part then? So let's see what options we have. First, we can keep it simple and keep relying on our unit tests, our functional component test, doesn't matter. And don't pay much more attention to the integration part, because if we introduce some changes to the contract, we will surely notify all the teams and dependencies we have. And let's see how this plays out. For example, let's try to release the provider. Let's say we develop some changes in the provider, put it as a version 1.1. And while we make these changes, bug fixes, whatever, we realize that with the payload, we are returning this active status as a string. And start wondering, why a string? Isn't it more logical to be a Boolean? Much better, I think. So we're not changing anything here in terms of how the service will behave and the logic. So we amend our unit tests. They should pass at that point. We deploy it on some testing or staging or maybe production environment. And then what happens is that we break the consumer, right? Why? Because we changed the contract, even involuntary. So this strategy is quite simple, which is great, but it also tends to be kind of risky in my experience, because only relying on our functional tests and our unit tests to make sure they flag to us that we've changed the contract is not always enough. And actually, if we are developing a complex system with many dependencies, many teams, a critical system even, we don't get the chance to make too many of these mistakes, and management is soon on our back, maybe demanding some proper testing. So why don't we put in some good old integration tests then? We know from the classical testing pyramid and from the example that I just showed that unit testing are actually a bit risky. But at the same time, the end-to-end, the other part, is something that we tend to avoid. We don't want this costly solution and invest too much in it. So why don't rely on integration testing instead? They should fit right in the middle and provide us real reliability, and actually at the same time not as costly as the end-to-end test we try to avoid. So let's see how this plays out. we're releasing the provider once again, the same version, but this time, not only unit test, but we throw in some integration stage there as well. In order to do that and make sure we don't break our consumer, we need to spin the consumer itself and run its integration tests against our pipeline. But not many teams, in my experience, like to do that, because actually running someone else's test is not fun. And also, we find out that there are other dependencies that we start taking care about in order to run the consumer. So in my experience, again, most of our teams just skip that if they were releasing the provider and didn't do that kind of testing. But what about if we're releasing the consumer? Here, the situation is much more common, I believe, and much more straightforward. Because if we're releasing this new version of the consumer, all we need to have is run our own integration test against the provider itself. All we need to do is to spin that provider in an environment along with the consumer, right? But at the point we start spinning it up, we realize it's not starting unless it has its direct dependencies. And then they have their own direct dependencies and their indirect dependencies, and they're the common stuff like authentication services, like tokens and so forth. And before we know it, we just spin up the whole environment, the whole stack, just to test this tiny integration part here, remember? And if one myth got busted for us at that point is that you can actually do integration testing in the small with microservices. The short answer is, in most cases, you just can't. You're just piling up on your end-to-end tests. And at that point, we also realized that we won't be able to achieve what we're striving, independent releases, keeping compatibility with all of these versions, because the consumer doesn't have only one provider in the real case, right? And ensuring all of these are working together with real integration, this is where integration environment hell actually is. We're killing a fly with an elephant gun here, like they say in English. So at that point, again, we started wondering, is it possible to have the benefits of unit tests and the reliability of real integration at the same time? Is it possible to have the cake and eat it too? Strangely enough, the answer to that question appears to be yes, it can, with something called contract testing. Now, contract testing, we already heard it mentioned several times during even this conference. It's nothing new, actually. It's been here for several years already. And what actually is a way to shift left our integration risks and to remove the complexity of real integration by starting to pay attention to the contract, to the API contract itself, and started taking benefit of the fact that we're working with APIs. So depending on who is defining the contracts, the tests, actually the contract test could be consumer-driven or provider-driven, with consumer-driven contract testing arguably being the more advanced and popular type of contract testing, with the help of tools like Pact, actually, which got very popular in recent years, I should say. And actually, this is what we this is the tool we actually tried when we first started experimenting with contract testing. So I'll try to briefly tell you how this works. A Pact is a combination of a mock server and a library, actually. So if you're trying to release the consumer this time, let's start with it. We are writing our expectations with the help of a Pact framework. We are defining our expectations from the provider, how this mock should look like. We are defining here, for example, this get existing user details case when we expect particular status, paywall, etc. from the consumer side. And then we are writing our unit test with framework we like, because Pact actually supports a lot of tools and languages and frameworks, and we are validating our request response from the consumer side against this specification, against this mock. This actually gets recorded by Pact as a JSON file, which, if we look inside it, is actually a series of interactions defined by our own test that we just did. And this is the contract. This is the consumer-driven contract. Then we need to run this against the pipeline of the provider in order, against the build of the provider, in order to know that our expectations are also kept in mind from the provider side, and both teams think the same. So again, the same scenario here from the provider side. All we need to do and need to have in the provider is the so-called state in order to put the service in a state that is needed for the test. And if everything goes okay, this signals back to the consumer pipeline, and it can be safely released to another stage or on production. And if we're releasing the provider, well, it's even more easy because we just need to fetch all the tests, all the contracts from our consumers and run them against our pipeline. How do we do that? Well, there are multiple ways, but maybe the most popular is an out-of-the-box solution called Pack Broker, which is actually an API service which serves as orchestrator for contracts between all the consumers and providers in the system. And what we actually got out of this experimentation is that we found out contract testing, and especially consumer-driven contract testing, is really a powerful concept because it gives you the reliability of integration, real integration at the cost of a unit test with a totally detached way. And actually, it also greatly improves the collaboration between the teams because they start communicating through tests and through code rather than the usual emails like they used to, which is, I believe, also always better. Something that's worth mentioning here is that consumer-driven contract testing is mostly applicable for internal APIs because, as you saw, we need to know who our consumers are. But where we struggled the most, I should admit, is the adoption part. Now, you already saw that in order to achieve that, with Pact in particular, you need to have that framework, you need to have that tool implemented in all your consumers and providers. And when we are talking, like in our case, this was already a build-up system with many services, many different teams with different maturity of their pipelines and and the teams as a whole. Actually, this proved out to be quite a costly exercise. And also you need to have the states like you saw. There's dependency on the implementation part, which you need to actually be ready to pay the cost to. And at that point, actually, we were not. And we were back at that point mostly to the drawing board, thinking whether we should go back and start relying on our so-called integration tests or actually end-to-end test and endure the pain. But at that point, we came across a very interesting concept of using specification-driven development and specification-driven API approach to contract testing. And actually, this came out as a really out-of-the-box solution for us because here, with specification-driven development, specification-first approach, the specification, most usually with the formula Swagger and Open API specification, is something that is either derived from the code or mostly the code is being derived from. And the implementation actually of the consumer and provider depends on the specification on this file. And because all our services mostly were already using this specification first approach, and we already had our code generated from the Swaggers, it was really out of the box when we found out there's a quite nice library developed, promoted by Atlassian called Swagger Request Validator. Actually, it's a set of libraries, but this is mostly what we used out of it, which allows you to validate your request response against your specification file. Let's say it's a Swagger file, and actually make sure that your implementation and your changes still adhere to the Swagger, which is actually your contract. And it gets even, you can see that you can do it with a few lines of code actually, and that also makes us confident that the Swagger is what we can promote for the consumers to use as well. And when we get to releasing the consumer, I would tend to say that it's even more powerful because you don't need real integration with the provider in this case as well. You just need to validate your request response against the provider Swagger file. where you can use it in multiple ways, for example, generating a mock out of it, or as it was in our case, we were heavily using wire mock. We just supercharged our mocks, validating them against the Swagger and making sure that our expectations on the consumer side are the same as the actual specification of the provider. And what we found out here is that it's really lightweight approach that allows for multiple implementation, and a lot of the dependencies that I just showed you with tools like Pact and consumer-driven can be skipped if needed. And also, this is an approach, as you can see, this is provider-driven, but it can also be complemented with consumer-driven approach because Swagger Request Validator Library supports Pact framework. The tricky part, I should say here, is the comparison with the Swagger, because we heavily rely on the structure of the Swagger on OpenAPI specification. But all the stuff that we came across, actually we found suitable workarounds, so there were no showstoppers there. And this is how our pipelines look now. For example, if we're releasing the provider, we are just running our unit tests, our component functional tests, and then we're running the contract tests, again, without any need for actual environment here. We are just validating the Swagger file again, the changes again, the Swagger file, and then we deploy and promote to some end-to-end testing environment or even production, depending on the case. And actually, an important question for us was how we distribute the Swaggers in this case, because you see a lot of our environments, we have a lot of stacks, and they're mostly dynamically generated out of the pipeline. They're not long-lived environments. So we needed to, we didn't want to have one service running there for all our stacks, orchestrating everything across the board. And so we decided to go for a solution which uploaded the Swagger directly into Artifactory, from where it actually can be fetched. Of course, you need to have some specific naming convention, some uniqueness to the file, so you can track the versions as well. And then that's done with the provider. And if you want to release the consumer, it's more or less the same stages. And when we get to the contract testing, we just fetch the Swagger file, test our changes against that. And if everything's okay, we deploy and promote. So as a recap, I would like to tell you that, yeah, as I mentioned in the beginning, it's really been a journey of trial and error for us. But I guess it gave us a lot of perspective. And I believe we finally found a very suitable solution for us to scale and be able to scale that to all our teams. And this works very well up to now in our context. But especially because this is our context, it might not be yours. So I hope that everything you heard and saw in this presentation, you take with a grain of salt and you put it through your own perspective. And I sincerely hope that if you found something new or interesting in this presentation, you seek it out and try it out for yourself, you experiment with it. Because after all, software and technology are changing constantly. And if we want our test to be a helper rather than an impediment, I believe we should be adapting and improving our testing approaches and tools as well. Because if we fail to do so, isn't actually that the greatest sin in testing? Thank you.